AVL trees, simple rotations. What do I mean by a simple rotation? Well, first and foremost, a rotation is the technique that AVL trees use to rebalance itself every time an insertion or removal causes it to become unbalanced. In this video, we're going to deal with just the simple cases where an AVL tree becomes unbalanced and how we handle that. Then in the next video, we'll go over the slightly more advanced situations. Situation 1. Suppose this is my tree, which is currently balanced. The height of the right side is 0, and the height of the left side is 1. So currently as it stands, there's no problem. Suppose I call insert 5. Since 5 is smaller than both 10 and 15, 5 will go to the far left. Now the height of my left side is 2, and the height of the right side is 0, giving me a height difference of 2. The tree is now unbalanced. This case, I call it the left case. So what we do in the left case is we label the 3 nodes A, B, and C in an increasing order. Then we rotate it once to make B the root, thus solving the imbalance. Next case, suppose this is my tree, which is currently balanced. Then I call insert 20. Since 20 is larger than both 10 and 15, 20 will go to the far right. Now the tree's unbalanced. I call this the right case. What do we do here? Once again, label the 3 nodes A, B, and C in increasing order. Then rotate left to once again make B the root, thus solving the imbalance. Next case, suppose this is my tree, which is currently balanced. Then I call insert 10. Since 10 is less than 15 but larger than 5, 10 becomes the right child of 5. I call this case the left-right case. What do I do here? Once again, label the 3 nodes A, B, and C in increasing order. Then what we're going to do now is we're going to do a double rotation. We're going to do 2 rotations. First, we're going to rotate at node A. Then I'm going to rotate at node C to make B the root once again. Then, in this fourth and final case, once again, I have a balanced tree. I call insert 15. 15 is larger than 10 but less than 20, so 15 becomes the left child of 20. Now my tree is imbalanced. I call this the right-left case. What do we do here? You probably guessed it. Label the 3 nodes A, B, and C in increasing order, and then we're going to do another double rotation. We're going to rotate right, then we're going to rotate left to make B the root, thus solving the imbalance. Now, each case we've seen so far where the tree became unbalanced, each time it became unbalanced as a result of an insertion. However, an insertion is not the only operation that can cause a tree to become unbalanced. A removal can do so as well. For example, suppose this is my tree, which is currently balanced. The height of the left side is 2, and the height of the right side is 1, giving us a height difference of 1, which, according to AVL standards, is okay. Now suppose I call remove 20. 20 gets removed, the height of the right tree decreases to 0. Now the height difference between the left and right side is 2, thus making the tree imbalanced. What we now have here is a situation identical to case 1, the left case. And we're going to handle this case the exact same way we handled it earlier. We're going to label the 3 nodes A, B, and C in increasing order, then rotate right to make B the root. Then suppose this is my tree, which is currently balanced, and I call remove 5. 5 is now gone. Now the tree is not imbalanced. What we have here is a situation identical to case 2, the right case. And we're going to handle that situation the exact same way we handled it earlier. Label the 3 nodes A, B, and C in increasing order, then rotate left to make B the root, thus solving the imbalance. In this next case, we have another tree that's currently balanced. However, if I call remove 20, 20 is now gone, and now the tree is unbalanced, and we have a case identical to case 3, the left-right case that we examined earlier. And we're going to handle it the exact same way we handled it then. Label the 3 nodes A, B, and C in increasing order, then do a double rotation. First, rotate left, then rotate right to make B the root of the tree. Then in this fourth and final case, I once again have a tree that's currently balanced, but if I call remove 5 from it, 5 is gone, and now the tree is unbalanced. And we now have a situation identical to case 4, right-left case. And we're going to handle it the same way we handled it earlier. We're going to label the 3 nodes A, B, and C in increasing order. Then we're going to do a double rotation. We're first going to rotate right, then we're going to rotate left to make B3, thus solving that imbalance.